for stuff, or
I can do everything but get to the one.
Stat edit.
Good job.
That's the when you do the whole thing, it's like the y equals mx plus b.
Oh, okay.
We haven't really done.
I
haven't done a very good job with that. So
I asked Trent. He said, don't ask me. And I was like, oh, crap. I got the numbers.
So, like, all I want you to do right now, don't worry about the regression equation. I haven't really taught that very well yet. Do the calculator thing. That's what I want you to do. Go to the calculator, do stat, calc, linear regression, all that, graph it. That's what I want to review. Can you show me?
Yes.
That was fast.
You hit bars.
So, eventually, yes, stat,
Hit stat again.
calc,
I'm not done.
linear regression, then do bars.
Oh, that's not bad. Why is it?
Why aren't you giving me that?
And now if you go zoom in and do stat, you see the graph. Now you're going to show center.
I didn't give you that.
Yeah. Go down to there. So I mean, it was an accident, but so it's not L1. It's second. Then go there and put bars. Bars, and then we get to the bars, and then y bars, function, y1, that's calculated.
I promise that's right.
That is zoom.
What's wrong?
Zoom and then zoom step.
Is it like sour?
I don't get any. I don't have any levels. It's not like that.
You're like dots?
Yeah, are you supposed to have like the
Did you do zoom and then zoom step?
Yeah.
I don't think I've seen that one.
I'm pretty sure I did everything correctly.
I mean, you must have data or it wouldn't have like made the line. Oh, your stat plot's on it.
Oh, where did that happen?
Right? Like, I don't know how it went by.
Thank you.
Does everybody else need help getting the calculator part squared away? Stat. Well. Linear regression for. Bars.
She said, "Yo, girl, cut to the application."
Zoom. That's what I learned.
If you do like early action, I would do that because
Somebody else
it's
get
not
the
that
calculator?
hard. What? You just put it on.
Side radio, you got part you squared away? No?
I
Oh,
fell
Sam.
asleep.
And
I
I
woke
was
up
like,
this
did you
morning.
rise the cable and stuff?
That's my story, crying.
Maybe
And then I was like, my computer might have
I'll have my driver's test tomorrow. Oh, that's fine. Oh, yeah. I'll pass for you.
I accidentally calculated everything for 4. And I told her, she's like,
new story.
I was like, she was like super chill. Like I like her. She can be rude sometimes. But like class. Well, she.
Okay. So I'm just gonna run through it real quick. I mean, partially because I haven't done it, but then you can like go watch. So edit. We're gonna go up to the top, hit clear, enter. Clear, enter. Shut up. Type it in the data. Stat, calc, linear regression. Then mine, so some of you have that menu. If you have the menu, you're going down to where it says like store regression equation. R's for variables, y variables, function, y1. So you should get this, and we haven't really done this yet, and that's kind of on me. But find the regression equation. Well, that's the regression equation. But you gotta write it a little bit better. So there's two ways I can write the regression equation. I'm gonna show you both right here. One is you can go y hat. So I haven't talked about this hat yet. So y hat means these are not actual y values that this equation is giving us. These are predicted or expected y values that the equation is giving us. And then you can go, so it's ax plus b, right? Like it gives you the form right here. What's a? Is your 0.16. Plus b, which is 4.2. But that equation is lacking something. It is lacking context. So there's two ways we can handle this. So first of all, before I get into the context, is there other questions about like how I'm getting that equation from that calculator output? Is that good? Alright, so if we lack context. Like I don't know what this means. What are you telling me? Why? What's y? What's x? So there's two ways you can do it. Over here, after you wrote your equation, you can say y equals, is it the ACT score or IQ that is y? So we're trying to predict the ACT scores. The thing you're trying to predict is your y. So then I can go, okay, y is ACT, x is IQ. And then you've given me the equation, and I can look off to the side and see what y and x are, and I know what the equation's about. Or you could go ACT hat, and I'm just plugging the context into the equation. Equals 0.163 times IQ plus 4.2. And both those are acceptable. I don't care which is which. Everyone has like their own preference. But they're both accomplishing the same thing. I can look at that equation and I can tell the slope. So you tell me, what's the slope? 0.163. I can tell the y-intercept. 4.2. I can tell the y value, what the y is representing. I can tell what the x is representing. So either one of those. Questions on that right there? Alright, interpret the slope. So the slope is 0.163. And I put some notes on the board, and this is the same thing we did on your, like in Schoology, but just to help you remember it. Slope is if the x value, but in context, right? So what's the x value in this case? IQ. So if IQ increases by 1, you expect, you don't have to underline it, I'm just doing it to remind you. ACT to increase or decrease? Increase y. How do I know that? It's positive. It also kind of makes sense, right? If you get smarter, your ACT score probably will go down by 0.163. So let me just review that. Why did I put IQ there? What is that representing? The x value. Okay, try and shut up. No one else. Someone else talk. Don't forget the word expect. Why did I put ACT here? That's the y, and then why did I put increase? Positive, and 0.163. No offense intended, Trevor. Interpret the y-intercept. Tell whether or not it makes sense in a real life situation. So the y-intercept, is like up here on a graph. So that would be like 0, 4.2. You don't have to do that. So the idea is it represents when x is 0, what's the y value? Like that's what the y-intercept is telling us. Do you have a question? Was that like a grunt of understanding?
Yeah.
That's awesome. Alright, so if what goes here? If blank is 0. I can't put x, I'm gonna put context. So you're right, but so if IQ is 0, we expect it to be dead, really, but we expect ACT to be 4.2. So if you have literally 0 IQ, you still get a 4.2 with ACT. I would say no. I don't think they'd ask that. I don't know. There's some really dumb persons. You said persons. I don't think they would ask that because it is kind of like, well, I don't know. Could you have a 0 IQ? Would you be able to breathe if you had a 0 IQ? I don't know. These are things I don't know the answers to. Wow. Alright, why did I put IQ here? It's X. Why did I put 0 here? It's like the y-intercept, yep. And then why did I put ACT here? It's the y. And then 4.2 is your y. So find R and interpret it. So we gotta look at our calculator. So I got R equals 0.863. You guys get the same thing? If you're ever in doubt, put more decimals rather than less. And then interpret it, so put that up there too. I'm going to tell the direction, which is positive or negative. In this case, we are positive, so it's positive slope. I'm going to tell the strength, 0.863. So moderate, strong, weak, what do we think? It's pretty strong, that's pretty close to 1. And I'm going to put context. So there is a positive, strong, you could say moderately strong relationship. You have to have context also between IQ and ACT. For R it does, or for the? Is that for describe the data, or for R? Do you have a graph? Because let's say I give you this. I can go draw a line through that, and that R is not going to be bad. Like that might be 0.8 or so, but is that linear? So then you know it's linear.
You say it was missing. Yeah, they wrote it. Linear or non-linear.
So you don't even have to know if it's linear or not. You just say it. Okay. I mean that's more fair.
I was just asking that.
No, I wouldn't. So if I ask you to describe R on a test, I would give you a graph, so you would know if it was linear. Like I either wouldn't expect you to say linear, or I'd give you a graph so you can tell. Is that fair? Does that answer your question? Alright, which variable is explanatory? So explanatory is the X. That's IQ. The response is ACT. And then, like I know, describe the data on Khan. That's for outliers also.
Yeah.
I won't ask you for outliers. And from what I've seen, the AP test is not either. I'm not quite sure why Khan does, but it's all concept. I guess. So describe the data. So it's up there, form, direction, strength, and then put it in context. So the form, linear or non-linear, and that's why we graph it. that linear or curved? It's linear. If it's curved, it'll be very obvious that it's curved. Like, it'll look like that. It'll be very curved. So there's a linear. And then the rest of it we've kind of already done. It's positive. It's strong. And then context. There's a linear. Positive. Strong relationship between IQ and ACT. All right, don't turn the page yet. Actually. So we're gonna go back to this table, and I kind of wrote. I didn't really intend to write it there, but we're gonna squeeze things in. We're gonna put ACT hat here in the middle. What does the hat mean? Predicted. Hat means predicted. Stop. It's not that fun. Hat means. I think it's hilarious they call it hat. Yeah, that's not like me making it up. I'm not that clever. And then we're going to put another column over here. That's residual. This is the stuff in con that we didn't cover yet. I might have screwed you on like your organization because I wrote over here. I apologize if that's the case. Do you need this term? Right, easy. Alright, so the residual is the distance above or below the line. So like this person here, at the very end, the equation would have predicted that they got this score. Whatever this y value is on the line. They actually got this score. So did they do better or worse than we would have predicted? They did better. That's a positive residual because they are above expectations. This person, the line would have predicted that they would be up here. They actually got an ACT down here. So did they do better or worse than we predicted? They did worse, and this would be a negative residual. So above the line is positive, below the line is negative. Above the line is like you outperformed expectations. Below the line is you kind of underperformed expectations. All right, so we're going to find that for each one of these scores. So, this equation right here, or whichever you want, is what I use to find the predicted. So if someone has 100 IQ, I'm going to go 0.163 times 100 plus 4.2. I'm just plugging their IQ into my equation. I get 20.5. That's what the equation would have predicted that person would get. 100 IQ would predict an ACT score of 20.5. And all I'm doing there is plugging this 100 into IQ in our predictor equation. Yes. Like, yeah. So I want to find, can I do that at the next point? So for 120, what ACT score would our equation predict an IQ of 120 to get on the ACT? So I'm taking 120, I'm just putting it right there in my equation. So I'm going 0.163 times 120 plus 4.2, and now it's a giant polarity. And so our equation would predict if you got a 120 on the, or if you have a 120 IQ, I plug that in there. Our equation would predict that your ACT score would be 23.76. That helps, Sarita? You thought I was doing magic calculator work? I was just plugging. So then plug in 150. 0.163 times 150 plus 4.2. 28.65. You guys see what I'm doing? Someone say no. I mean, you mumbled something. Are you good? We got it. Go back to the second one. It's a little loose.
You're not good enough to get arrested. Yep. Is that actually what he said? Yes.
This is like this is what the line would have predicted. Well, the data doesn't match always, right? You know what I'm saying? So finish that. Cut those. Get the rest of those. You guys get what I'm getting? You're a power returner now?
Like 5 yards max. It goes like 30 yards in the air and then like 5 yards forward.
That'd be like impossible to return though.
Yeah, it's kind of weird. That's what we're worried about. They're so bad that we're worried it mess us up because they don't know what they're doing.
Can you guys do better so we can do better?
Yeah, man, it's like they're gonna line up so weird because they don't know where to line up that it might mess us up.
I mean, you should also be able to find some
Oh yeah, no,
exploits and things too.
Yeah,
Yeah.
They don't have like read them by policies.
But they don't like do it.
we didn't have.
There's no keys to follow.
We have to try to figure out what they're doing because they don't know what they're doing.
Right. If you're rounding like slightly different, don't worry about it. But make sure you're getting the numbers I'm getting. If you're not, let me know.
The second to last IQ is 70.
How many times are you gonna make IQ jokes? We good there? Or we need more time? Is everybody still getting the numbers? Only 5, you are. I'm just asking. What are you targeting? You're not targeting.
So for
I didn't do residual yet. Are you good? Right. So the residual, this column here, the residual is the actual minus the predicted. So I remember that because you are in AP stats. That's the order. Actual minus predicted, AP, A minus B, you know what I'm saying? Or it's alphabetical. Actual minus predicted. But the idea is that, like, these are the scores that make that line. Like if I graph these, I'll get that line that goes through the middle of your points. But actual data is not like exactly what you expect, right? And these are the actual data points. So there's a difference between them. So the residual is the actual score, which is the ACT, minus the predicted score, which is the ACT hat. So like this residual is 0.5. Would this be above our line or below our line? this person do better than we thought they would do, or worse? Better. Above the line, outperformed expectations, did better, positive residual. Positive. Above the line. Outperformed. And then yeah, go fill those in. You guys matching my numbers? Questions on what I'm doing to get this? So if I was just kind of go over that process again. We started here. Started with just the data. I go to my calculator. I find the equation of the regression line. Put a hat on top of the y. So that's golden. That means expected. And then I plug in the IQ scores to give me the predicted ACT scores. And I match those up with the actual ACT scores. And I subtract actual minus predicted, A minus P, AP stats. And then I get the residual over here. So who, let's say I label these people A, B, C, D, E, G, H. Which person outperformed their expected score by the most? G did, right? Because they have the largest positive number. Who underperformed the most? F? Did you say F? Who got the closest to what they would have been expected to get? J, because that's the closest to zero. Like, what would the residual be if you got exactly what you were supposed to get? It'd be zero. So that's the closest to zero, right? Questions on this chart? Where'd you do this? Why'd you do this? Okay. Now we're going to make another chart. Go to the back page. Make a chart that looks like that. You're going to put residual on the y-axis, and we're going to put our x value on the x-axis. What's our x value? What's our x context? So our IQs went from like 70 to 150. And our residuals are go to like 5, positive and negative. I think that covers it. residuals from the previous page. So, for example, this person that had, and I apologize for flipping back and forth, there's not much I can do, but the person that had an IQ of 100, their residual was a 0.5. They were 0.5 above the line, they outperformed by 0.5, so we're going to find 100 here, just kind of estimate 0.5. Person that has 120 IQ has a residual of negative 0.76, so it's probably like right on my number. You see what I'm doing to put the points on there? 150 has a residual of 3.35, so I'm going over to 150. Try to match it up with about 3.35. You don't have to be super accurate. Bless you. It's somewhere around there. That's not what I'm stepping in. Keep going. And if you look at your graph, if you turned your graph so that the line that we made through it is horizontal, do you see how that matches up? I made this point like way too high. It's probably down here. But that's really all we're doing. Just plotting the above or below the line, but like horizontally instead of on our diagonal graph. You get what I'm saying? Like this point and this point, those are the same. We got like these two above the line over here, which are these two above the line here. It's kind of a quick way to check. Am I good to go on? Okay. So, if your residual plot shows randomness, so that's kind of random, right? There's no real pattern there. That means the data is linear. So a linear model is a good fit. A linear model is appropriate. If the residual plot shows a curve, which I'll show you in a second, the data is not. So you want randomness. So you can be like, yeah, we did it right, linear model. So just to kind of show you this again, I'll show you a curve. So because I can look at, and you don't even necessarily need the residual plot to see this, like I can look at this, be like, yeah, if I just rotated that and made it horizontal, there's no real like pattern there. Got kind of a down, up, down, up. There's not like an obvious curve. That means the data is linear. I went over here and I put one in that is a curve. So if I look at the if I did the residual plot, it would basically just turn it sideways. You see how there's a curve of those points? Your residual plot would have that exact same curve. And then if I asked you if that data is linear, you would say no. Because the residuals are perfect. Does that make sense? Okay. Two more things here and then we're good. We'll finish the rest of it tomorrow. What does it mean if the residual is positive? Overperformed expectation, and we're above the line. The residual is negative, we underperformed. Expectation, we're below. Robert, you got a question? You good? Okay. So then we'll finish this up tomorrow, and I have like a computer thing for you as well. It's not a game, bro. Connor might love it though. I'm curious how you guys feel about. So when I say take-home test, everyone's like yes, but keep in mind with a take-home test, that can make it a lot harder. How many prefer a take-home test that will be harder to an in-class test? It will be easier. How many prefer an or you could just be like, I don't care either. How many prefer a take-home test? How many prefer an in-class test? How many don't really care either way? Okay. Well, the problem is I don't want to give you a test on a Monday and we got like a half day Friday and then it'd be like, so I don't know if we're going to finish the material in time to have an in-class test.